Hi, welcome back to Mr. Chemistry, Gas Density Problem Lesson 1. In this particular lesson, we're going to look at two gas density problems. The first problem, what is the density of N2O4 dinitrogen tetroxide at STP? And the second problem is, what is the density of SO3 sulfur trioxide at STP? Well, these problems are actually pretty simple. First thing you need to know is the density formula for this particular problem. So density equals molar mass times the pressure divided by the universal gas constant, R, times the temperature. Now, when you look at STP, what does STP really mean? That means 1 atm of pressure at standard temperature, which is 273.15 K. That's Kelvin. Notice that we don't see degrees Kelvin because that would be incorrect. It's just simply Kelvin. Alright, so let's look at what we know. Alright, first of all, we need to know what the molar mass of N2O4 is. That will give us our capital M. So to figure that out, we have to set this up as N2O4. So we're going to look at a periodic table, and nitrogen is 14.01 grams per mole. See that? And oxygen, which is 15.99 grams per mole, we're just going to simply call that 16.00 grams per mole. Alright, so let's go ahead and get an eraser here and clean up some space. Clean that up there real quickly. And now that gives us some space to work with. Alright. So anyway, when we go ahead and put this together, what we get is 28.02 grams per mole. That was pretty easy. 2 times 14.01. Then we do 4 times 16, which is going to give us 64.00 grams per mole. All you have to do is add things up. 2, 0, 2, add 1 over, that'll be 9. 92.02 grams per mole. You thought this was going to be hard. This is really super duper easy. So now we know what our M value is. Our molar mass for N2O4 is 92.02. So D equals 92.02 grams per mole, right? Times our pressure. Our pressure is at STP. Remember we said that was going to be 1 divided by, now this R is our universal gas constant. It's always going to be 0.0821 liters times atmospheres over moles times Kelvin. Pretty simple. Times our temperature. Now at STP, our temperature is going to be 273.5 K, because that is the standard temperature at STP. So let's go and put that in there. 270. Thought this was going to be hard. All you got to do is cancel out your common units. That's simple. ATMs cancel out ATMs. Wow. Kelvin cancels Kelvin. Moles cancel moles. So all we have to do is multiply the top and bottom. So we get D equals 92.02 on top, and that's in grams. Right? Pretty simple. That's what's left. Divided by 0.0821 times 273. That's roughly 22.4 liters. So now all I gotta do is divide the top by the bottom, and our density is going to equal 4.9 10 grams per liter. Now that was pretty simple. All right, let's go to the next problem. What is the density of SO3, which is sulfur trioxide, at STP? Now we already know that STP is 1 atm, and the standard temperature is 273.15 K. So we don't have to go back and think about that anymore. So the first thing we'll do is we'll write our formula again. D equals MP RT. All right, so we want to find the molar mass. We want to find M first, okay? In this case, we have 1 sulfur. If you look on the periodic table, sulfur is 32.06 grams per mole. Wow, that's easy. Then we have 3 oxygens. So we have 3 times, remember it's going to be 16.00 grams per mole, not 15.99. You could use 15.99, but why make things harder than they really have to be, right? So let's go put a line right there. This gives us 32.06 grams per mole. And this is going to give us 48.00 grams per mole. So when we add these guys up, we're going to get this to equal 80.06 grams per mole. And that's our M value right there, okay? So our pressure, we already know that's going to be 1 atm. Our R value never changes. It's going to be 0.0821 liters times atmospheres over moles times Kelvin. And our temperature is not going to change either because it's at STP, so it's got to be 273.15. So let's go put everything in. D equals 80.06 grams per mole times our pressure, 1 atm. Oh, okay, that's easy. Divided by that R value, which we said was 0.0821 liters times atmospheres over moles times Kelvin times 273.15 K, just Kelvin. Our K's cancel out. They're gone. Our atmospheres will cancel out. That's gone. Our moles will cancel out. That's going to give us grams over liters. All right, pretty simple. So D equals 80.06 grams divided by 22.4 liters. So our density is going to equal 3.57 grams per liter. And that's it. This was really simple. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly. I will see you back here at Moosing Chemistry.